Alright guys, we're going to start our fourth unit. It is chapter 3, and we are going to talk about quadratics in this unit. Just a reminder, quadratics are your x squared functions, and also hopefully you have printed out your notes, or you're going to write down notes as we go along, but you need to at least see what we're dealing with here. So we're going to break this into a couple days. So hopefully this video won't be too awful long today. Hopefully you know what the parent function of f of x looks like. You should know that it goes like this if it opens up, or it goes like this if it opens down. And for all quadratic functions, there will be a point somewhere that is the vertex. Okay. It is either the maximum or the minimum point, and there is a standard form or that for this. And typically, we sometimes call this vertex form, but this is what. But you can see in your notes what it looks like. It's f of x equals a times x minus h squared plus k. And the ordered pair hk is the vertex. So if you have this in the standard form, or in what we sometimes call as vertex form, you can just pull out the vertex very easily. Keep in mind this minus sign changes what goes into the parentheses. So if you have minus 3, then what goes into parentheses is 3. So basically you're changing your signs. And then you look at A. The other thing that we're going to talk about today is looking at A. And hopefully you all remember that if A is positive, then we open up. And if A is negative, then we open down. Okay. You find your axis of symmetry. Okay, axis of symmetry. By taking h, which is your axis of symmetry, and it's the opposite of b, over 2a. Now, why is the axis of symmetry important? Well, if you look at these graphs up here, I can draw a line that goes straight through the middle, and what do you notice is on that line? The vertex. The x value of the vertex is on the axis of symmetry. This formula right here, opposite of b minus 2a, gives you the x value of the vertex. So this is the x value of the vertex. Okay. And then how would you find the y value of the vertex? Well, you would plug the x value into your formula and solve for y. So k equals f of h, to put it in math terms. All right, so we're going to work on numbers 1 through 8 in your notes today, and then that'll be it. So I'm going to go ahead and clear my slide, and let's go ahead and start working on number 1. Now, hopefully you can read along. You have to identify the vertex. You have to describe the graph, which means that it states the transformations. Okay. And you have to write the quadratic in standard form. Okay. So we have f of x equals 3 times x minus 8 squared plus 7. Okay, so the first thing we want is the vertex. And what's nice is this is in the standard form for you, so the vertex is going to be the quantity 8, 7. Don't have to do any work. It's very nice. How does this open up? Well, this is A. How does it open? It's positive, so it opens up. And last but not least, the transformation. Well, the transformation is at 3. That is, you should know this, a vertical stretch. Okay. And that's it for number 1. So let's look at number 2. F of x equals negative 1/2 times x, the quantity x plus 3 squared minus 7. Okay, what's my vertex going to be? Well, this says positive 3, so I change it to negative 3. Always change that sign. This is negative 7. Well, it stays negative 7. So my vertex is negative 3, negative 7. And again, it's nice that this particular problem is in your standard form. Okay, so what happens? We open up. Do we? No, we open down. Why is it down? Because this is a negative 1/2. Okay, so it opens down, and this would be a vertical shrink because the value is less than 1. Not because it's negative. The only thing the negative does is make sure it's opening down. Okay, 2 of our 8 problems for today are done already. Let's move on to number 3. Number 3 states a little bit different. We have f of x is equal to x squared minus 6x plus 12. Okay, so this is the other form. This is the way you're used to seeing quadratics. So we need to make this into standard form so we can answer all the questions. Well, first off, a is equal to 1. That's still the number in front of the x squared. The h value, remember, is the opposite of b over 2a. So that's the opposite of negative 6, which is positive 6, over 2 times 1, which equals 6 over 2, which is 3. Okay? So now I need to plug this 3 into my formula. So I want f of 3, and that'll give me k. So that is 3 squared minus 6 times 3 plus 12. 3 squared is 9 minus 18. Wow, that's like really bad. Plus 12. So 9 minus 18 is negative 9. Negative 9 plus 12 is 3. So my vertex is going to be the point 3, 3. So how do I put this into standard form? Well, f of x equals a times x minus k, I'm sorry, minus h squared plus k. And we know it opens up because a is positive. Okay? Let's do number 4. I've got f of x is equal to negative x squared plus 4x plus 3. So in this case, a is negative 1. Okay. And then how do I find my h and my k? H is equal to opposite of b over 2a. So I have negative 4 over 2 times negative 1. Well, negative 4 divided by negative 2 is positive 2. Now, f of 2 is equal to k, which is equal to negative 2 squared plus 4 times 2 plus 3. Now, guys, a lot of you are having problems with order of operations. What do you do first? Do you do a negative or do you do a square? This negative is in front and it's not part of the problem, so we do 2 squared first and then change the sign. So 2 squared is 4, so this becomes negative 4 plus 8 plus 3. Negative 4 plus 8 is 4 plus 3 is 7, so that gives me the rest of my vertex, which is 2, 7. And now we have a very easy answer for the ability to put it into vertex form. We have f of x is equal to negative 1 times x minus 2 squared plus 7. Okay. So guys, I've done 4 problems. I told you there's going to be eight of them total. I'm going to do 6, and the other 2 are going to be for you to practice with. Okay, so I'm going to leave number 7 and 8 for you all to practice with, after you watch this video. But let's do number 5, getting just a little bit more complicated each time. F of x is equal to 2x squared plus 4x plus 3. Now we have a is equal to 2, all right, and we need to find our vertex. So h is equal to the opposite of b over 2a. So I've got negative 4 over 2 times 2, or negative 4 divided by 4, which gives me negative 1. K equals f of negative 1. So we plug that in, we get 2 times negative 1 squared plus 4 times negative 1 plus 3. Negative 1 squared is 1, so we get 2 times 1 is 2, plus negative 4 plus 3. 2 plus negative 4 is negative 2. Negative 2 plus 3 is 1. So our vertex is negative 1, 1. So in vertex form, or in standard form, also known as vertex form, we have 2 times x plus 1 squared plus 1. And what do we know? We know it opens up. Can't forget this part. And we know that we have a vertical stretch because the number is greater than 1. Last one that I'm going to do. F of x is equal to 1/2 x squared plus 8x. Alright, so our a is equal to 1/2. Our h is going to be negative b over 2a again. So I got negative 8 over 2 times 1/2, or hopefully you all see that is negative 8. Now, k equals f of negative 8. So I plug that in there. 1/2 times negative 8 squared plus 8 times negative 8. Alright, so I've got 1/2 of 64 plus negative 64. Or I've got 32 plus negative 64, or negative 32. So my ordered pair for my vertex is negative 8, comma, negative 32. in vertex form, we have f of x equals 1/2 times x plus 8 squared minus 32. We know that we open up, and we have a vertical what? It is not a stretch because this is a fraction now. If it's a fraction, then it's a vertical what? It is a vertical shrink. Doing so well with my handwriting right now. Okay, guys, that's the last problem that I'm going to do. What I would like you all to do, and it's on the honor system, just in your notes right there on your page, I want you to do number 7 and number 8, and tomorrow, when I pick up from where we left off here, for the next part of the lesson, I'm going to start with making sure you have the right answers for 7 and 8. All right, guys, have a great day, and I'll talk to you tomorrow.